So let's look at the object in Python. So object is I would say a relative new concept to you guys. But if you look back to the previous lectures, you actually it's everywhere. Um, if we go back to this simple example, that is a conversion of the Europe floor to the US one. First, you can use a input function and ask user to input a floor, and which is a Europe one, right? And then some calculation will be done, and the US floor will be computed. So this, if you look at this piece of code, very simple one, basically it follows this flow. So you have an input, right? And you have some process with the input. And turns out the output will be obtained through the process, and then you output it. So that's the code, I would say, organized by the process, which I mean organized in the in this process oriented, meaning it's a straightforward. You have input, you have a process, you have output. But in many times, this is not sufficient. You want to have a better way to organize your code. And that's what the object-oriented programming does. So in this object-oriented programming, a program is made up of many cooperating objects. So instead of being a whole program, this each object is a little island within the program, and they interact or cooperatively working with each other, with the other object. But still, at the same time, they are relatively independent to each other. You can tell, okay, this is object one, this is object two, and they work together for something, and they exchange information by some mechanism, and so on and so forth. But if we go back to this block of simple code, basically there's no um, such an island there. So everything are put together, and you cannot tell which one's which part, right? So you can you can tell the difference. And basically, if you have the object oriented programming, you actually put a lot of objects together, and the object will utilize each other's capacity, meaning you can use some, one object could utilize some other object's capacity or capabilities to achieve certain tasks, which will be more powerful than those process-oriented programming. And if we look at the object more carefully, so you might ask, what is an object? Actually, an object is a bit of self-contained code and data. It's not just the code, but also data. And you organize this code and data together and put it into an object. So that's how the object work. Basically, the idea for using the object is you are breaking down a big problems into several smaller ones, several smaller parts. And these parts not only smaller, but also is easier to understand. So that's why we need this object approaches to achieve many tasks. Another thing is, as described in the previous slides, the objects are like isolated boundaries, right? I mean, like isolated islands. So they are floating on the sea, in the sea, and they have a way to connect with each other, but still there is a distinct boundary between each of the objects. And also for other object, for example, you have object A and object B. They work together to achieve some task. Basically, object A only care about certain functions, certain data object B possessed. On the other hand, object B only care about some of the useful code and also data to achieve that specific task. So all other things will be ignored to each other. So that's a beauty for the object. You can have much more codes and data stored in that object. But when two objects work together, or two or multiple one work together, each of these objects only care about a portion of the data and the code of from other object, and all the rest will be ignored for the specific tasks. If you look at our previous lectures, actually we are using object all the way through. Like the string actually is an object. And also integer, even integer is an object. The data structure dictionary is an object. Also the list. So also the tuples. So these are all objects. So as you with these like string or tuples, you should be able to understand. Basically, when you want to process something, when you want to, for example, extract the email address from a document, you are using some functions or data of string objects or dictionary object or the tuple object. All the rest has no need in this specific task, so they are ignored. For other scenario, you might need some other functions or the codes or data from the string objects, dictionary object, and so on, and you will use that piece of code and data, and all the rest again are ignored for that specific question. So that's how the object will work together. Any questions so far? Okay, let's move on. So, sorry. Sorry about that. I need to clear my throat. Okay, let's see. If we take the object-oriented programming for the same tasks, again, there will be some input, right? And but in the program itself, you can see there are several interconnected objects, and the data and functions are utilized between them. And turns out there will be some objects which are the result from this program. And as you can see, the user-defined object like these are working together with the Python sorry, the Python built-in object like string and dictionary. They work together to achieve certain tasks. And that's how the object-oriented programming work. The object get created and utilized during the process. And if we look the definition of object, actually each of the objects need no matter it's a user-defined one or the built-in ones, they are all code and data, combination of code and data, and they work together and interact with each other. It turns out they work together to achieve certain tasks. So there are several definitions in an object. The first one is so-called class. And the class is a template of the object. And it's like, and also we have the method and messages. So that's the defined capabilities of a class. And usually it's like some functions, right? Which is specifically for that class. Also, you have some data, which usually called a field or attribute. So it's a series of data in the class. Another concept is object or instance. So this represents a particular instance of the class. So class is like a object. It's a conceptual. It's a conceptual thing. It's an abstract thing. But the object and the instance is more like your, for example, a dog actually is more like an abstract name, right? But if you are talking about the dog you are keeping, that's the object. That's the or instance if we have this analog. So that basically the template defines how that object will look like, some of the behavior that object have. But when you utilize it, you cannot just use an abstract thing. You need to have this object or instance defined, realized. So that's the relationship between a class and a specific object or instance. Any questions so far? Okay, I will show you some example in the later slides, and you can understand better. So here shows the definition of class. Again, as I mentioned previously, it's the abstract characteristic of a thing, right? This abstract characteristic is the keywords. And also, it includes the attributes, field, and the properties, as well as the behaviors. Basically, that represents the both the data and also the codes or the methods represents the object. Someone also say a class is like a blueprint or factory that describes the nature of something. Again, if we take the dog as an example, so the class dog would consist of the traits shared by all dogs, some as breed and fur colors. And these specific features, actually, we call it characteristic of that class. And also it consists of the ability to bark and sit. These are the behaviors. So both the characteristic and behaviors would represent that object, and that is defined in the class. All right. So again, the instance, the instance of a class, basically that's the actual object created when you run the code, right? In the program jargon, for example, if you have again, if we take the dog as an example, and you define a object called Lacy, and Lacy actually is an instance of the dog class. It's a specific object, but it is a dog class. So Lacy probably shares the attributes and the characteristic of all dog would do, like she will bark, she can sit, and she might be like a Labrador Retriever, or she has a really nice goat fur or something like this, like that. So again, this specific object is an instance of a dog of a abstract class. So that's the relationship between an object or an instance versus the class. And when usually we will use the object or instance, they are usually interchangeable. So they are at most places, these two, either of these represent the same thing. They represent the same thing. When we talk about some specific thing of an abstract class. All right, so that's the instance or object. Another thing is the method, right? That's the object's abilities. Basically, it's like functions. If you ever use the string object, there's a function called len, right? So if you call this function, you use this function, it will return the length of that string. So basically, it has the ability to tell you what is the length of the string. In that sense, it does something to you for you and give you some information, and that's an object's ability or method. If we look at the dog class as an example. So we have an instance Lacey, and she's a dog, right? Um, Basically, she has the ability to bark, and so bark could be one of the Lacey's methods or abilities. Also, she might have other methods as well, like sit, eat, walk, or save Timmy's, or so on and so forth. These are all the ability Lacey have or the dog uh, class has. And basically, within the program, you can utilize this method to achieve some tasks, either independently or work together with other objects or other piece of code. So that's how the method represents in the object. Also, again, the method and the message are often used interchangeably, meaning they represent the same thing in the context of a object. So again, if you look at the in the Python built-in object like this X, so it turns out X is a string, right? And you type it, it tells you, okay, it's a class string. If you, I don't know if you have noticed or not, if you use a type, there will be a keyword class. So this class is exactly what I was talking about. It is an abstract, and it is a string, right? So it gives you the type. ABC is a string, right? And this X or ABC is an instance, right? Also, if you use the type to check this 2.5, it gives you a floating number, right? And if you type, you put a 2 here, it gives you the class integer. Also, you can have some class list or dictionary and so on and so forth. Also, another very useful function is called dir. It will shows all the methods that a object has. And as you can see here, if you you put dir here for the x actually is a string, right? It shows all the method a string has. These are all the methods, all the functions. I used to call it functions, but if we talk about in the context of a object or a class, we should call it method, right? These are all the method a string has or X has in this specific case. And if we look at the methods for Y, which is a list, and again, it shows all the methods for a list for Y. And also for the dictionary, these are all the methods for dictionary. Okay, any questions so far? Okay, I think because you've already used these objects, I think you have some ideas about it, how you would use it. So let's take a even more closer, a closer look to class. For example, we have a class called party animal, right? It could be an animal or a person, right? But let's define as such a class. And remember, class is a reserved word. Basically, you cannot use it as a variable name. It is reserved by the Python, and that is represented by that represents the class of an object, right? So you have such class, and for this class, there's a variable, there's a data x, which is assigned to be zero. And also here shows a definition of a method. So this method called party, and it takes the variable self or the parameter self. Basically, self literally that means self. That means this specific objects itself. And if you what this party want to do with self, basically what it does is it access the x and add 1 to that x. Turns out you have your x increased by 1, meaning you have another party, and you attend a new party, and the total amount of party you attended will be increased by 1. So that's what this function does. Of course, you print the result, print so far and how many parties there. So this is a method, and this is the data stored in this class. And remember again, this is an abstract thing. It's not a specific thing. What you want to do is you want to utilize this template and create an instant or an object. But what you do is something like this. This n is an instant, and you just call this so-called the construction function, and call this. You actually construct a object which is party animal type or party animal class, and then assign this object to this variable n. And it turns out you have an instant of the party animal class. Of course, you can utilize the method after you create this object, and it turns out you can use the method party, and because the variable here self means itself, so you don't need to put the variable here because it will take itself to complete the task defined in this function. So basically you call 3 times of the method, and that is how you utilize the method of an object or a class. Any questions? So similar to any other variables, a class has to be defined first, and then it can be utilized by us. So you have to have a class definition first, like the one showing here, and then you can utilize it to create the instance of that class. So again, this party animal class. So as if we visualize this instance like this, what you can see is, well, within this instance n, what you have is a data stored and a function available. So also this data, this x, is initialized to be 0 because defined in the class, it is initialized to be 0 here. And you have this function party, right? And it is available to be called by the object n. When you call this function, actually it will run the code like this, and turns out it will print the result. So when you first run call this party function, what it does is basically x plus 1, because x is initialized to be 0, and 0 plus 1 is 1, so x becomes 1 at this time. And then print out so far x now is 1, so it print out so far 1, right? And then when you call this party function second times, it will go inside this function again, and now this self dot x is 1, right? 1 plus 1, and the self dot x becomes 2, and then print it out so far 2, and it does the same things the third time when you call this function the third time, and the result is so far 3. So that's how it works. So basically, again, this class defines how it looks like, what it does for each instance belonging to this class, and that's how it works when you have an instance created for that class. Any questions? Okay. Another thing is when you define this abstract class, you just basically defined what it will do. It will be done if you call that function. It actually does nothing. It just build the method, build the rule actually. When this code is actually executed, actually it's somewhere here. When you actually have an instance and call that function, call that method, then this block of code is actually executed, and there will be some result generated. So keep that in mind. All right, that's why you always need to call these methods. If just solely this definition, it does nothing. All right. So you can play with the dir function and the type function, and to any the object you defined or you created using the built-in class types. And here shows you some result. Also, we can utilize the dir function to find the capability of your own class. Basically, these classes are created or defined by the programmer themselves instead of the built-in ones. For example, you have the party animal, you have one data X or attribute X initialized to be 0, and you have this function which is called party. And then you define an instance, create an instance of the party animal class. And if you use the type to see the type of this instance, and turns out it will return this class name you defined. Also, if you use the dir function, and it turns out it will return this function, the method, and also this data variable. So that's how the dir and type function work. Not only with these built-in class type, but also the self-defined class types, which will help you especially when you are reading some code which are not written by you, right? You might need to see what's going on with that class, and how could you utilize it using the dir and type function. If you apply the dir function to a string, let's see you defined a string and X, and if you call dir function and apply it to this X, you will see all these methods as well as the attributes shown here, right? It's quite a lot, right? So you might ask, well, if you define the object, how it can be created and how it will be destroyed. The good thing for Python is it take care of these creation and destruction, which is a good thing, because in many other languages like C++, you have to create and destruct the object yourself, which could bring troubles to a large program, because you might, as a programmer, you might just forget to do so, which will cause the memory problems. The program will run slower and slower if you create too much, too many objects without destroying them if you do not need them. And that could be an issue. But for Python, that's very convenient, because Python take care of it. But still, you want to know when this is when the objects are created, used, and discarded or destroyed. Actually, there are two special methods or functions, which is called constructor and destructor. So it does the job. They do the job of construction of an instance, and the destruction of an instance of certain class type. Actually, constructor are used a lot, but the destructor are seldom used. The reason is, again, Python take care of the destruction for you. So you don't need to explicitly call the destructor. Basically, Python will handle it. But the only thing is you need to specify, you need to let Python know you want to create an instance of certain class. That's why the constructor are used quite frequently or used a lot. But I will show you a piece of code and demonstrate how this works. All right. So as I mentioned, the constructor actually is used to set up some instance variables with the proper initial values when you want to create an object. So if we look at this piece of code, again, you have a class called party animal, and that's the variable is initialized. And if you look at this strange function, it's very strange, right? But this is the constructor. And basically it has the initial, I mean the keywords initial, and it takes itself as the parameter. What this constructor does is it just print out a line of text, which is I am constructed. It does nothing but just print this. Another function which is defined by yourself is the party, right? We have it previously. So, and again, a very strange function with this keyword deal. That's the first three words, characters of delete. So that is the destructor. It will destruct this object or instance. And in this case, it does nothing but print another line of text and destructed. So once you have this defined, actually you don't need to define the this destructor or constructor explicitly. Python will if you do not define anything, Python will call the default one. Python will do it for you. So you don't actually need to do it. The only thing you want to do is define this kind of self-made or self-defined methods like the party. This function is defined by the programmer themselves. Usually, both the constructor and destructor will not be necessarily defined by the user, but we explicitly put it here, just let you know how it look like. So if you have this class defined and all the destructor, constructor, and some self-defined function there, and let's look at what it does. So first, you create a new instance like this. Once this line is running, once this line runs, what it does is it will run the constructor automatically, and the output will be this printing. So when this constructors run, it print out this line. I'm constructed. All right, and then you you call it the party function, and twice, right? First times x is 1, and second times x is 2, and you print the information as well, right? Then you have this line. So it's a little confusing here, right? Originally, n is assigned to be an object, but now you assign a number, an integer number to n, and what does it mean? Meaning, well, you do not need that object anymore. You assign another value, another object to this variable n, and the original object, which is a party animal type object, is not needed anymore. So when you do this, value assignment, what it does is the Python will automatically call the destructor of party animal, and it will destroy that object for you, and then assign this 42 to this variable, and the previous party animal object will not be existing anymore. So that's why you have this I'm destructed to printed. Basically, the destructor was run, and this line was printed. And turns out that is when that shows how the constructor and the destructor are utilized. All right. Any question? I think here is a little confusing. So if you have question, just let me know. Any questions so far? So again, although there's no explicitly function calling of this constructor, as long as you do not need that object and you are assigning a different value to this variable, that object will find its this constructor and destroy that object instance, and that's how it works. So basically, again, the Python take care of the destruction of an object, so you don't need to worry about it. And the only thing is you want to create an object, utilize it for something, and then Python handle it when you do not need it anymore. All right. So that's the definition of the constructor. Basically, a I think that's duplicated. All right. Okay. So once you understand the basics of Python's object, you could utilize it in many ways. The typical usage is you could create as many instances as you need as you can. So you can create a lot of objects utilizing the class. And again, class is a template for the object. Also, you can store all the each of the distinct object into its own variables. Basically, you define different variables, and that variable would contain a different object. And also for the same class, you could define many multiple instances for it. Each of the instance has own copy of the instant variables. Although they belongs to the same, I mean they are from the same class, but still they are individuals, right? They have their own copies. For example, although like Lacey and Bob, they are two dogs. They're all dogs. They all have eyes, two paws, but Lizzie has her own eyes and paws, and Bob has his own, right? So they have their own copies of these instance variables, and that's the way you understand it. Let's look at one example. Basically, again, we have a party animal, and we have two attributes. One is the times of a party you had, and another one is a name. All right. Basically, this party animal could have a name, right? And to initialize it, just put nothing here, right? Initially, it's an empty string. Again, for the constructors, you can construct the name to be something you want to pass to this function, and it will assign this string to name variable, and then print print the name and construct it. That's the constructor does. And also for the method party, right? What it does again, it will accumulate the times of party you had if there's a new party coming. All right. So understand with these understood. Basically, if you run 2 line of code like this, you create one instance, and also you initialize its name by passing Sally to the class, to the constructor, and it will run this constructor and assign Sally to name variable of this object. And after you complete all these, you will have this object to be assigned to S, variable S, right? Similarly, you create another object or instance with Jim as the name, and assigned the object to variable J. With these two variables assigned assigned to be assigned by these this object, you can call its method party. So s.party, so you will have the x to be accumulated by 1, and but that x is s, belongs to s. It has nothing to do with J's x. So J's x will be modified if you call J's party function, right? And the x of s will be updated again if you call the party of s again. So it turns out what you will the output would be, okay, first you have the construction, right? Construction function run. Basically it represents it is corresponding to these two lines, right? And then once you have, let me erase this. Once you run this line, it will accumulate the x and print it out. And similarly, for the object starting in J, you do the same thing, and then you call the party again for S, and it will accumulate 1 to the x again and print it out. So that's how things work with the object. And here you have multiple instances of the same class, J, S, and J. I mean, that's easy to understand. Even you have dog, but there are even let's see, the Lexi and Lacey and Bob are both dogs, but they are individual dogs, right? So similarly, both J, S, and J are are the party animal class, but they are different instance. They are individual, they are independent to each other. So any questions so far? Okay, let's continue. Another very interesting property the object has is it has the so-called inheritance. So the inheritance for object is actually quite similar to the inheritance of our human. For example, Jim's father left a legacy to Jim. So basically, Jim inherited her father's legacy, right? That, and also, if we talk about the appearance, usually the kids has similar like eye color or hair color from their parents. So basically, the young child inherited the hair color or some nose shape from their parents. So in other words, if we go back to the object, similarly, if we have a new class, we can reuse some of the capability and attributes of an existing class. And at the same time, this new class have some special or the some new stuff other than this existing one. So if that is the case, we can utilize the inheritance mechanism, which will make the code more compact. You don't want to duplicate everything for every class. And also sometimes you just want to maintain this logical relationship between one class to another. Basically, you want to have they're relevant to each other. So this new class, which usually called a child class, has all the capacity of the old class, which we call it a parent class. And then there will be some unique methods or attributes only this new class, this child class has, but this old class hasn't. So that is the inheritance. I mean, it's also easy to understand, right? Basically, the young child has some similar similar, like the young child has the same hair color or eye shape or eye color from their parents, but at the same time there will be some different features, like it has a I don't know, maybe a taller height, or maybe it has a more rounded face other than a long face, something like that. So that enables a way that is you reuse some math ability and attribute a old class has. At same times, you enable some new ability and new attributes, which you only want the new class has. So that's the how the inheritance work. So again, to explain this inheritance, basically the subclass are more specialized version of a class, which inherited attributes and behavior from their parents' class. Also, it could introduce their own attributes and behaviors. So for example, again, this party animal class. And let's say you have a football fan class, which is a child class of party animal. So what it does is it has this X and a name attributes. It inherits this from party animal, but it has its unique attributes points, and it has its unique method called touchdown. So it has the party method and also the constructor like this. At the same time, it has unique attributes points and also a unique method touchdown. So what it will look like will be like this. Again, you define a new instance for the party animal class and initialize it with Sally as the name. And the constructor function will be called, and the name will be initialized, and this line will be printed. And then you call the party function of S, and it will accumulate 1 to the X and print it out. It's very simple, right? And then you create a new instance for football fan and initialize the name to be Jim. Turns out it will call this constructor function, which is inherited from the party animal. And then the name will be set to be Jim. Also, if you call party, basically this party function will be called. Again, this party function is an inheritance from the party animal, right? At same times, this J variable could call, I mean, this football object could call the touchdown function. So this touchdown function is not an inheritance anymore. It is the unique function only football fan class has. And as you can see, you are saving a lot of code because this inheritance. These two functions are inherited from the party animal for the football fan subclass. And you could have this unique function defined and called as well. So that's how the inheritance work. And that's how this is very useful mechanisms in the object-oriented programming. Any questions so far? Nope. Okay, good. So if we visualize this object, as you can see here, if we view the S object as this block, actually the attributes is stored here, and also this name attributes is also here. But if you look at J, besides this X and the name, there is another attribute which is called points. So that is the new attributes which is not inherited from party animal, and it's only defined in the football fan. And you can, if you compare S and J, you can tell the difference, right? Because S is a party animal object, and J is a football fan object. Football fan is the inheritance of is a child of the party animal class, so it inherited the attribute from party animal. At the same time, there is a new attribute point, which party animal hasn't. All right. So any question? Okay, good. I think this is duplicated, but I think that's all the lectures for today. And basically, I would like to summarize. The object-oriented programming is a very good way to structure your code and organize your code. Basically, you could reuse your code by such a structured approach. Also, you could group the data and the functions together and create many independent instances of an abstract class. So I will let you to do some practice for this object part on Thursday's lab. And again, after, from next week, let's move on to some specific mathematical functions for Python, especially when we talk about some data analysis applications. So that's pretty much all for today's lecture. Thanks for your attention.
Are we going to use classes on Thursday for the lab?
Yes.
Okay.
Yeah,
just making
definitely.
sure.
Yeah. Yeah.
All right. Thanks. See you on Wednesday, Thursday.
Okay. See you guys.
Bye.
Professor,
Yeah.
Our office hours are still like available or going?
Oh yeah, yeah. Yeah,
Okay.
definitely. So you want to
yeah, on Thursday. So I'm almost done with the project. So I wanted like to check with you some questions about
sure,
it.
yeah. Yeah, please come to this meeting room on Thursday. I will ask you. I will answer your questions.
Okay, thank you.
But before that, let me know you will come. All right.
Okay, I'll send you an email.
Sure. Okay. Good. Good. Yeah.
Thank you.
Yeah.
Bye.
Mhm.